I tell you what, man. Yeah! What's up, guys? Which means that was about 10 seconds of yeah, and I feel good right now, man. I feel good. Some brain exercise. I think I'm gonna ask your teacher to pause right here and let's do this 5 minutes of brain exercise. Let's work out our brain. Let's have a look at this algebraic expression. Okay, so first we have to identify the like terms. But let me ask ourselves this. Let's ask ourselves this question: 3a squared and 2a, are they in the same gang or not? They're somewhat in the same gang, but in order to add each other, they need to be the same. But is the algebraic expression here a and a the same? Yes, but there's a square here. Therefore, they cannot do anything to each other. We cannot derive a much more simpler value. So we move on. We identify the a. Oh, there's a here. There's a square here. There's another a square here. There's another a square here. They can actually do something to each other. Okay? They can either add or they can what? Plus. So a square and a square. There's a constant here, negative 8. Negative 8. And there's a constant here, positive 1. So what we can do is we can once again rearrange them in cards. But as we can see, for every card, there's a symbol and there's a number. There's a symbol and there's an algebraic expression. There's a symbol and there's an algebraic coefficient. There's a symbol and a number constant. Symbol, coefficient. Where's the symbol here? If there's no symbol here, okay, by default, it is a positive. So now we can actually somewhat conjure them into cards. Okay, I'm gonna pause the video for a while so that I can draw my cards. Yeah! So the cards are already here. So the next time we need to actually identify which one do we. Okay, 3a squared and 6a squared. So ideally, let's move the a squares together. So I have this 6a squared here. I'll just put 3a squared beside it. Okay, next one, I have 2 plus 2a. Where's the other a? 7a. Okay, come, let's go. Okay, and then we have our constants. We take our minus 8 and we take our plus 1 so that they can be beside each other. Okay, there you have it. It's much more easier and simpler to do our algebraic expression here. So when we have the like terms here, 3a squared and 6a squared, we can, oops, wrong button, can actually add them together because they're in the same gang, a squared, a squared. So 6 plus 3 is 9, positive, don't forget the symbol, a squared. Positive 2a plus 7a will become, since the a gang, it will become the 9. Okay, and since there's a positive here, put a positive. Okay, what about this? Negative 8 plus 1. Negative 8 plus 1. If you're not sure what the answer is, some of you guys will give me 7, some of you guys will give me 9, so we're not sure. There's always the calculator, but remember your number line. Okay, there's a 0 here, and a minus 1, and minus, and so on. There's a minus 8 around here. When negative 8 plus 1 plus, we move to the left? No, we move to the right. We move to the right because of the addition, positive, it becomes, according to the number line, it becomes negative 7. Okay, so the 7, we put answer here, 7 here first, but there's a negative sign here, right? So we put a negative sign here as well. So when we compact the algebraic expression together, ultimately our answer will be positive 9a squared plus 9a minus 7. But of course, as you can see, initially there was no, at the start of every algebraic expression, there is no symbol. So, okay, since by default there's no symbol and it's a positive sign, we can remove the positive sign. So this is your answer. Let's take about a minute to look at this next question before we attempt this question. Okay, but tell you what, try to take about 2-3 minutes to try to solve this question yourself on a piece of paper or in your mind, whatever that works, and I'll go through in about 1 second time. By now we will have identified the same gang like terms. Okay, we have 5a square here, we have 3a square here, we have a 5 here, a constant here, no other constant anywhere else. There's a 6c here, there's a 4b here. So what are we gonna do now? Okay, we're gonna match the like terms together. So 5a square, and what a square is available here? 3a square plus 3a square. I imagine that they are cardboards. I move them and shift them together with the symbol in front and the variable or coefficient or the constant at the back. So for the rest, I will just rewrite whatever is as original. Okay, since I moved this plus for positive 3a square to the front, it's now blank and empty. I compact all the numbers, so it's plus 5. Okay, these two, I can do something about these two, but what about the rest? Think about it. Can we do something to the rest? Okay, these are not like terms. There's a C here, there's a B here. Sorry, C, carrot, B for banana, and a constant number here. We can't do anything about this. So we know that at the end of the day, the answer will have this at the back. Okay, so we settle whatever is at the front first, whatever the like terms together. Okay, 5a square plus 3a square will give me something a square, because in the a square gang, 5 plus 3 is 8. And what about the rest? You just bring the rest and copy down whatever is from the question. Okay, so there you have it. This is your answer. Okay, it looks confusing at first. You might not be confident, but this is actually the answer, because you can reason out. The rest are not like terms. The rest are, we need to actually figure out which one are the like terms, and we settle them together. Okay. Now look at that. Look at that. Look at that question. Respect that question. Let's take about 1 minute, 2 minutes to actually figure this out. But there's before you attempt, we need to actually take note that there is what here? There is a bracket here. So Bodmer's rule, bracket, you have to settle the bracket. There's like a gang war inside here. Settle, expand the bracket. When you expand the bracket, you need to actually take the symbol. You need to multiply with every value inside the bracket. Okay, let's take about 1 minute to do this question. Then again, bear in mind, for negative, multiply with negative will give you. Okay, never mind, you guys try first. Okay, by now I would have resumed the video and you will have done all your working. So here we settle the bracket first. Okay, so negative times negative, negative times negative, as we remembered from Sec1, it will give us positive. Okay, negative times negative is positive. We bring the value. Alright, what about 9? Negative times negative 9 is negative times negative is positive. Negative, when they somehow try to produce themselves with negative, they become positive. So bring the value down here as well. Okay, negative times positive will give us negative 5a squared. Alright, I need you guys to recap and wear a thinking cap. And whatever is at the top, we need to just write everything down. It is squared minus e plus 7 plus 3a. Now we can actually group the like terms together. Okay, so bear with me for a while. So what are the like terms? We have the a square family. We have the 5a. We have the a square family here. Another one. We have the number family, the constant, the 9, the 7, and we have the last but not least, the a family. The a family. So let's group them together. Like ideally, we put the squares in front first. So I'm gonna take a color. So where's my 8a squared? What's the symbol here? By default, if there's nothing, it's positive. Okay, let's move the 5a square beside 8a square. So since 5 there's a negative sign here, we bring the symbol as well, minus 5a square. Okay, next up, we have the a family. Okay, would it be easier to put a negative a at the front first or positive a first? I think it's nice if we just put the positive in front first. So 3a. So we bring the negative a. Okay, then while I'm doing this, I need to take note. Oh, I'm done with 8a. I'm done with 5a. I'm done with 3a. I'm done with negative a. Now I'm only left with positive 7 and positive 9. So I just rewrite whatever is at the top. Alright, okay, now I can settle. The war is about to be over. 8a square minus 5a square will give us something from the a square family. 5 minus 8 is 3a square. Okay, sorry about that. Okay, positive 3a minus a. 3 apple minus 1 apple will give me something out of the a family. 3 minus 1a here will give me 2a. Of course, algebra we do not write 1a, we just write it as a. Okay, positive 7 adds positive 9 will give us 16, and since it will give us a positive number, we put a positive number here. 3a minus a is a positive 2a, so we put a positive here. Therefore, this is your answer, 3a squared plus 2a plus 16. And there you have it. If you ask me why is algebra like that, I will just answer you, it's like that, and that's the way it is. I say, huh!